Okay, hello everyone. We will be starting in few minutes. Till then, let's watch the official theme of Kshitij 2022. Okay. So, hello everyone. I am Samriddhi Sinha and welcome to our third virtual exhibition of Kshitij IIT Kharagpur by Festo, prime movers in the field of industrial automation and technical education on their project Bionicswift. Festo is a global player and an independent family-owned company with headquarters in Esslingen am Neckar, Germany. The Bionic Learning Network, an association of Festo with renowned universities, institutes, and development companies, provides new impulses for technical applications and industrial practice inspired by nature. The creation of the Bionic Swift represents the next chapter for Festo in the development of bionic flying objects. Today, we have with us Mrs. Caroline Van Haffen, who is the designer and head of corporate bionic projects at Festo. Her main activities are conceptual design and project management in the Bionic Learning Network. After completing her industrial design studies at the Hochschule in Pforzheim and a MBA in general management, she held various positions at Festo, including head of product design, until she took over as a head of bionics at Festo in 2018. So without any further ado, let's start with it. There are some great projects developed by Festo, and here is a video on various bionic flying objects by the Bionic Flying Network. So these were some great flying objects developed by Festo. And today we have the Bionicswift, a robotic bird that weighs just 42 grams despite having a body length of 44.5 centimeters and a wingspan of 68 centimeters. This makes it extremely agile, nimble, and capable of flying loops and making tight turns. By interacting with a radio-based indoor navigation system, the robotic birds are able to move autonomously in a coordinated pattern in a defined airspace. So here we have a video on the Bionicswift. Okay, so now we have with us Mrs. Caroline Van Hoffen, who would now be demonstrating and explaining about the Bionic Swift model. Ma'am, hello, ma'am.
So hello, everyone. I'm Caroline von Heven. It's a great pleasure for me to speak to you today at the Indian Institute of Technology. I would like to present the Bionicswift to you, which I have here with me. You have seen the short video for the Bionicswift, so you know already the agile flying behavior of the Bionicswift. And it's my pleasure to introduce the Swift a little bit more in detail to you. Just show it around in front of the camera so you can see it more from a closer view. You can see the single feathers on the wing that lie shingle-like over each other, like for a natural plumage of a bird. We have built this wing according to the role model of a swift or a swallow to get the highest aerodynamic properties. The single feathers ensure that during wing stroke, the feathers can open when going upwards to save energy or close when moving downwards for a strong wing stroke. The Bionicswift is a lightweight construction, so it weighs only 42 grams, and the size is around 80 centimeter of the wingspan. We're using a special material for the feathers to get it lightweight. And we're also using 3D printing technology to get all the high function integration that is necessary to bring this bird into the air. I show you a little bit of the inside construction. Here we have a 3D printed part, which is in the body of the Bionicswift. All the batteries and PCB boards, electronics is mounted into this structure, which is both at the same time endurable, stable, and lightweight. This part here makes the moving part of the wing. So the wing can be combined to this part here, and so make the flapping wing mechanism. Inside of this structure, we have a lot of gear wheels, similar to this. And mounting the gear into the structure makes the movement possible. Next part, we have the tail of the bird, which is also built up from the same lightweight material, kind of a foam. And the tail will be combined with the inside structure of the bird and gives extra guidance for flight stability during flight. Here you have it again, the construction inside of the body, all the necessary parts. The flapping wing mechanism is something that is really difficult to construct because inside of this bird is no helium or other gas. It flies simply by flapping with its wings, like its natural role model. With the Bionicswift, we showed for the first time also a swarm behavior where we're using a kind of an indoor GPS, which works on a radio basis. Each Swift has a given track that it follows, as you have seen in the video. And even if the Swifts are deviated from their track, they can come back autonomously to their given track. So looking at my box here, what else do I have to show? Maybe again, the wings, it's a little bit easier with this part here. You see the shape that it gets when it's winding, like for big rotators or propellers, similar shape. And we have a carbon rod structure here where the single feathers are mounted on. I think these are the basic elements of the Bionicswift. And I hope I could explain a little bit how it's built, how it's set up. And now I'm happy to answer some questions of you.
Yes, thank you, ma'am, for showing and explaining about the Bionicswift. It was really delightful to see the model and its features and also advancements in your project. So there are a few questions which are asked by our participants, and it would be great you can answer a few of them. And also, if anyone who here have questions, they can put up in the chat box, and we will address them after this. Slides are visible, right? Yes, ma'am. So, like, my first question we have is, like, can we make a bionic bird which can learn from the actions of the actual bird and imitate their actions?
This is a very good idea to train a flying robot machine after the natural role models. In this case, we could not give the bird the intelligence to learn from the real role model. Instead, one of our engineers, you have seen him in the video, did this work and taught the flying robot to fly.
Yes, ma'am. So another question we have is, like, since the model is very lightweighted, so can it withstand the air drag at certain heights?
Mhm. This bird is built for indoor flying because of the very lightweight construction and using the lightweight material. And also, if you see this, filigrane setup, we can use it only for indoor flight because outside there is too much wind or conditions that would do some harm to the bird.
Okay, ma'am. So the next question we have is, like, what were the roadblocks or the difficulties that it was faced when the build for the building of the Bionic Swift?
Yeah, as you can imagine, in such a project, there is a lot of roadblocks or hurdles to compete with. And one thing is, of course, the flapping wing mechanism. So make it lightweight and durable, to make it also energy efficient so that the bird can fly a few minutes with one battery load. We also had the gearbox, which was really challenging to find the right combination here. And we had a lot of investigation to find the right material that is lightweight at the same time, strong enough to cope with the wing strokes.
Yes, ma'am. So another question we have is, like, since it uses the radio-based indoor GPS, so can it interfere with other frequency waves which can affect this GPS?
We're using this radio-based GPS system because inside of the building we don't have the GPS signal. And we also wanted to define a certain space where the birds should fly and where they should not fly. So this is why we're using this radio-based indoor GPS. We have tried other indoor GPS systems, but this one pointed out to be the best one.
Okay, ma'am. So the next question we have is, how are the features designed in this Bionic Swift? As you said, it's for the efficient flight and capable of flying loops and turns as well.
So inside of the Bionic Swift, we have a lot of electronics and control systems. So first we train the bird, of course, with a telemanipulation and train it and find out how is the aerodynamic behavior, how agile are the Swifts, what maneuvers are possible. And then later this will be done by the control algorithms and electronics.
Okay, ma'am, that was great. Uh, so I think now we can take the questions from the audience. We can move on to the chat box. So one question we have is, how did you decide the carbon fiber placement in the Bionic Swift?
Mhm. I take this wing here for the example. We have tried out a lot of different variants here. And it was really challenging to find out the right angle of the carbon rods, also this geometry here, because it's very important is the other side of the feathers. So this row here, because during flight, this line here gets longer, goes like this, or gets shorter if it goes the other way. And the carbon rods, they should take all the energy and force to hold the feathers stable and to ensure that this mechanism is working fine.
Okay, next question we have, person is asking asking what is the name of the material that you used for the feathers.
So I'll show it in detail. Of course, I can't tell you the specific name of it, but as you see, it's a very thin layer, thin material. It's like a foam a little bit. So it gets a surface that is smooth on this side and is a little more rough on the other side. And this is ideally suited for the air turbulences you get to make a stable flight.
Yes, ma'am. And the person is asking like, can you repeat the part of the structure of the core body which you were saying?
I should repeat what?
The structure of the core body part that you were explaining.
So I can show it again here, the structure of the core. Um, I would not repeat the explanation since this is recorded. You could look it up a few minutes earlier, but to show it again, here is the structure where we can put in the PCB boards, the battery, and all the necessary electronics.
Okay, so another person is asking like, can you make this model using 3D printer?
Yes, like this structure, we're using the 3D printing, but of course for the wing, it's not possible to use the 3D printing due to the weight we get, and also, like I pointed out, the material features that we can't reach with the 3D printing.
Okay, ma'am. So another question we have is, what is the longevity of one model and how is the flight efficiency of flapping wings flight as compared to any fixed wing flight?
Can you repeat the question, please?
Yes, ma'am. So the question is like, first part is what is the longevity of this one model and how is this flight efficiency of flapping wings in comparison to the fixed wing flight?
Mhm. Um, the flapping wing mechanism allows the bird to stay in the air and make its movement uh, and do these maneuvers. If we have the fixed wings, the bird itself could only, how do you call it, sail. So, like you make a paper plane and throw it. This could be done with a fixed wing, but with a flapping wing, the bird can stay in the air and go also up and reach some height.
Another question we have is what are the electronic gadgets are there in the core body?
So the basic electronic setup is a battery that we put in. It's a lithium polymer accu that has enough energy for 3 to 4 minutes. I don't have the electronics here, but I can show where it's put it. Then we have the central main board for the flight control. And on this main board, we have another PCB for the radio system. And then we have, of course, the gearbox, which is mechanical. Yeah, that's it. Very simple.
Yes, ma'am. Another question we have is the framework for the body inspired by the arboreal nature of the role model?
And please, can I have the question again?
Yes, ma'am. The question is the framework for the body inspired by the arboreal nature of the role model?
Mhm. So the inside of the bird, as you can see, is not really close to a bird skeleton, but we have put in the principles here of the bones and skeletons when it comes to stability and but not when it comes to shape. Here we had also to take into account to fit all the components in it, and this is what a normal bird does not have, a controller or a motor, and so on. So the shape looks, of course, a little different than the normal skeleton.
Uh, one another person is asking like what is the motive of a DRDO bird and what the features of that?
What is the DRDO bot? I don't know this word.
I think if the person can write about it.
I do not understand the question. I'm sorry.
Yes, ma'am. I think the person hasn't uh, written completely about DRDO.
Okay, like a drone. Yeah, no, I see. Um, no, this is this is totally different to a drone because this bird cannot hover in the air or stay in the same place. It has to go forwards all the time. If the wings stop with flapping, the birds will fall down.
Okay, ma'am. So if any more questions are there, you can put up in the chat box. Yes, ma'am. Another question we have is what features does a flying object attain when it is designed like a bird?
So with these flying robots like the Bionicswift, we try to find out a lot about energy efficiency, about lightweight construction, about function integration. These are all relevant topics for our core business here at Festo. So using these future concepts, we learn a lot about important topics for our products that help our customers.
Yes, ma'am. So I think okay. One question is asking like if a person wants to build at a home, so how can they try to build a simple model of this kind of robotic bird at home?
A good idea. I think you need a lot of creativity. And if you have a 3D printer, I think it's helpful to try out a few things. And yeah, just be inspired. It is possible and try it out.
Okay. So one more question we have is like can you mention that topology optimism for the framework and how do you find what's the frequency of the flapping birds?
So the flying is all tested out, let's say trial and error. So first we try to get it in the air to look that it's flying at all, a few minutes. And then we try to refine step by step, take out the friction, lose more weight, get better material, and so improve the flight maneuvers and agility.
Okay, ma'am. So I think there aren't any more questions. Yes, one more question is there like can wireless charging be implemented so it can fly longer?
Yeah, we have thought about this and found it really difficult to bring another flying object close to the Swift to make wireless charging possible.
And one more question we have is like what is the flying time of this bird?
Um, the Bionic Swift has a flying time of around 3 to 4 minutes.
Okay. So I think there are not any more questions. We will just wait a few more minutes if there are more questions. Okay, I think we have come to an end of the session, and I, on behalf of Kshitij, is grateful to you and your team for such a delightful session. And I'm sure the participants who attended the session felt the same. So thank you very much for the session, and also a hearty thank you to the audience for showing your interest throughout the session. And also, Kshitij has started some regional events, and so do follow Kshitij on Instagram to stay updated about such interesting events. And do register for the events, and the link for which you can find in the chat box. So thank you, ma'am, and thank you, everyone.
Thank you very much. You're welcome. It was a great pleasure for me.
Thank you very much, ma'am.